today on exponential. Oh gosh, I should have slipped my little thing. And logarithmic equations. Okay, equations today. We're going to be solving some stuff. Alright, so let me tell you, I made up this worksheet of all word problems that we're going to be doing. And my goal was to have everyone's name in a word problem. Well, I have 3 classes doing this stuff, and I quickly found out that would be like 60 problems. So we're going to do this worksheet in a couple days, and your name may or may not be on there. And if it's not, I'm sorry, but at least you're not doing 60 problems, okay? Yeah. So there's that. You can take no comfort. In that. Yeah, you can take comfort in the fact that you don't have 60 problems. 15. Yeah, 15. All right, so doing exponential and logarithm equations. Remember about the exponents and the logarithms. Remember they're inverses of each other. Okay, they undo each other. We're going to see some ways where you can solve it without having to use an inverse function. But just remember, they are inverses of each other. Like if you had an equation with multiplication, you would do the inverse, which is division. Division, right. So we're going to get to the point where we're going to have an equation with a logarithm, and we'll have to do the inverse, which is an exponent. It's a lot easier with like addition and subtraction and multiplication and division to know that they're inverses because it just seems more natural that they're opposites of each other. If you add it and then take it away, like if I give it to you and take it back, those are opposites. That makes sense. But it doesn't always make sense that when you take it to a power and then you do a logarithm, that one undoes the other. It doesn't quite make sense. So you just need to remember these are inverses and they undo each other. And sometimes you don't even have to do that. Sometimes it's really easy. Let's look at an easy exponential function. Okay? How do I know this is an exponential function and not just some function or equation, not a function? This is an exponential equation and not just some equation with an exponent. What's the difference? Right. The variable is actually inside the exponent. So that makes it exponential. Okay? I could do some logarithm stuff here if I wanted to, but I actually don't have to. This has a base of 2, and this number over here is 32. Guess what?
There's 2?
It also has a base of 2. Yeah. Does anybody know what it is? It's on the board over there. 2 to the 5th. Yeah, if I multiply 2 times itself 5 times, I get 32. Right, so x plus 1 equals 5. We do know how to solve this part, right?
Yeah.
Okay, what do I need to do? Love x equals 4. That's your answer. So sometimes they're super easy like this. Here, I'm going to give you one with a 3. 3. Hey! You got here just in time. I just got started. Thank you very much. Alright, so this is 3 to the x minus 2 equals 81. No logarithms needed here. You can just finagle that 81, mess with its base a little bit, and see what's going on. What did you change the 81 to? Okay, so that means that this is actually x minus 2 equals 4. What are you now?
Don't you subtract 2?
They subtracted. Add 2.
Never mind. I'm lying. I'm sorry.
X is 6.
Yeah, I was so close.
You have to use the 3. What do you mean? Well, if I change it to 9 squared, then I don't have matching bases, and I can't just set the exponents
Okay,
equal.
so yep.
The bases have to match before you can put the exponents equal. Yeah. Good question. Bless you.
Thank you.
Did it hurt?
No.
Okay.
I nearly cut my eye out.
Just checking. Okay. Alright. Now let's look at this one. This one's a little bit different.
Is this still the same thing?
Same stuff. 5 to the x equals 40. Okay. Now why can't I do with this one what I did with the other one?
Because it doesn't equate.
Right. Well, that, and I don't know what, like, 40 doesn't break down to a power of 5. Like, 27 could be a power of 3. 16 could be a power of 2. 40, no. I got nothing. Okay? So I can't just reduce this and set my two exponents equal. This one's going to require a logarithm. Okay? This one, I have to do an inverse function here. Tell me one more time. Why do I need an inverse function of a logarithm here?
It doesn't have a
Right. What if it said 5 to the x equals 125? Then I would be fine, right? But it doesn't say 25, doesn't say 125, doesn't say 625, doesn't say anything that is a power of 5. So it's 40, so I need a logarithm here, okay? Because what's the inverse of an exponential function? Logarithmic function. Yes, a logarithmic function. They are inverses of each other. One undoes the other one. Okay. So what I'm going to do, since my calculator will do common logs, I'm going to do a common log. And whatever you do to one side, you have to do the other. So I'm going to say, okay, well, let me just take a log over here. And that means I have to do it over here too. Okay, according to our little rules, our blue rules, where can that x now go? In front. So now, instead of log of 5 to the x, it's x times the log of 5 equals the log of 40. And everybody in this room knows what I can do to undo x times something, right? What do I do? Divide by it. So I'm going to divide by the log of 5. Divide by the log of 5. X is now by itself. I'm going to get my calculator. I could use that chart, but I don't want to. Because today you are free to use your calculators all day long. Mine's taking like 6 years to climb. Alright, so log 40, close your parentheses. Closing the parentheses is very important. Is this humorous? I don't know. Yes, it is. Alright. Log of 40 divided by log of 5. 2.2920. Did everybody get this in a calculator? Alright, I'm going to show you. Alright, so it's the log button right there. Log 40 divided by log 5. Oh yeah, that takes like a year. Yeah. Everybody get it?
I was staring at my calculator like, where is the log button? She was like, just go to that.
Alright, try this one. Try this one. This is the exact same problem, but with different numbers. Okay? Exact same process. Look at your example we just did. I'll even put it back on the previous example once you get the problem written down. Follow the exact same steps. Okay? Can I remove it? You got it written down? Alright. Alright, so, what do I do first? Alright, take the log of both sides. Whatever you do to one side, you have to do to the other. And then what happens with that x? Yep. Then what happens? what does x equal? 2.3 what? What's after the 9?
Two.
Okay. Alright, good. Unless you're told otherwise, we generally go to 4 decimal places with logarithms. That's kind of the unwritten rule. If they tell you round to the nearest tenth or hundredth or whatever, then fine. Otherwise, it's alright, so let's look at one that's a little bit more involved. Same kind of process, because a little bit more algebra in it. By the way, you don't have to use log, you can use natural log. Let's use natural log on this one just to show you. It's the exact same rules. You can use either one of them.
So it doesn't matter which one you use, you have to.
Yep. Okay, so on this one, we're still going to take the log of both sides. Except I'm going to do a natural log. Yesterday, someone said lateral dog instead of natural log, like they got all tongue tied. It was hilarious. These still come forward. The natural log, the base is e, the number e, and a common log, the base is 10. That's the only difference. That's a different base. Okay, now at this point, if we were to divide right now, we would not get x by itself. So, and my goal is to get x by itself. So I'm going to tell you what I'm going to do, and then I'm going to actually do it, okay? I am going to distribute this log throughout on both sides, like this. And then I'm going to get the x's on one side, the non-x values on the other side, factor out an x, and divide. Yeah, it sounds crazy, but it's really not that bad. Alright, so that's going to give me 2x natural log of 3 minus the natural log of 3 equals x natural log of 5 plus 2 natural log of 5. It's pretty easy to multiply a log times something because you just stick it on the front and there's not actually any multiplication happening. You just write them side by side. So that's pretty simple. Alright, so this is going to go over there, and this one is going to come over here, okay? So that will be 2x natural log of 3 minus x natural log of 5 equals 2 natural log of 5. What 3? Right here? No, I just wrote it weird, I guess. Okay, so now you see how both of these have an x value? I can factor that out, and I'm left with 2 times the natural log of 3 minus the natural log of 5. It's 2 natural log of 5 plus natural log of 3. Now do you see why I had to do all that? There's just one x sitting here by itself. That one x, and I can just divide that. Ooh, look at that. And x will equal whatever this is. Now let's talk about putting this in your calculator. To put this in your calculator exactly like it is, if you open up a parenthesis here, put these in parentheses, this in parentheses, and close a parenthesis. Then your divided button, open up a parenthesis, just like that. So do you see how many parentheses are going on there? Log or natural log. I'm going to do natural log. Notice that this one right here will probably open up automatically on your calculator. Okay? Alright, so let's see. 2 natural log. Boom. Natural log 3. Boom, boom. That boom, boom, that was those two parentheses right there.
I'll let you use that.
Jeremy. Where?
I don't know if I'm doing this right. Wow, this was... The only thing that's getting me is...
It's not right?
I got 3.29.
I got
10.2. 7.3, yes, 7.3. It should start with 7.3 and go from there.
I was starting to get nervous. I was like, no.
Yes, it's the 7.3 number. Okay, if you did not get 7.3, don't erase anything from your calculator. I want to see it.
This.
You're probably going to do your step by step on that calculator. Yeah. Oh, wait, what was yours? You said you didn't get it? Oh, okay. Who said they didn't get it? Okay, so you got it now? You got it now? Alright, awesome.
3, 4, 5, 6.
Yeah, 7.3453. Excellent. Okay.
Anyone writes this size like that, I feel so totally like it.
No, I can't breathe.
How do you feel you put the first line of
What first line?
First line of red.
Here?
No, red.
Oh, red, right here? That was distributing this through. Like that.
And then when you moved them, how did you know where to move them?
I put this, because it doesn't have an X, it went over there. And this one does have an X, so it came over here.
So you just switch them
I just switch it. I want my X's on one side and my non-X having numbers on the other side because I want to be able to factor an X out like I did right here. So it's just X times, like that X is all by itself times all this stuff, so then I can just divide. Yeah. Alright. It's your turn. No. Like, wait, what? Nobody said anything about us having a turn. X minus 2. 4. X plus 2. Okay, same steps as the last problem, but different numbers. Same overall steps, okay?